All right, welcome back. It's been a while since I've seen you. I've been pretty sick for 2 weeks. I haven't been this sick in I can't remember how long with the flu. Last time I was this laid up was probably 2010. I got food poisoning, but that was different. And for the flu, man, I can't remember last time. I've been hammered for 2 weeks plus, 2.5 weeks. Getting mostly over it, but I can't recollect the last thing I talked to you guys about. I think it was probably, we were doing memory, and we did the diagrams up on the board, and then we did IPOS, and we did the categorization of different hardware components. So today will just be a little bit of a lecture catch-up day. Here I know I've done these slides, and we'll just breeze through 4, 5, and 6 and talk about what stands out. So we are in week 6. That's the first thing you need to know. So all of your assignments through week 6 need to be done. Make sure you're also paying attention to extra credit. There's some good extra credit, 5%, 5%, 5%, 5%. 20% of your grade you could earn here in extra credit. You earn that extra credit, it totally makes the pressure and everything else less, right? Less pressure. Project Do-Good's a simple extra credit assignment. It's more of a humanistic, philosophical, related to ethics. University of the People is just good to know about. Who could tell me about University of the People? Nobody. So it's a place, it's an accredited university. It's accredited. So it's a degree that counts. It's from a legit university like National or whatever the other ones are, right? And it's free. And it's all online. So you could get your bachelor's degree for like $4,000. It's $100 a class, or less if you qualify for low-income fee waiver. That's pretty amazing. A bachelor's degree for $4,000. Just do it all online. So that's great to know about. And if you go and you investigate it and you go through the application process, you don't have to go to the point. You don't have to pay. But if you get up to the point where you pay, take a screenshot. I'll give you extra credit because I think it's that important to know about. And then the Excel training and Google Power Searching, those will actually ask you to work. But you'll learn really good stuff in each of them. So investigate them. If they're interesting to you, do them some weekend or over 2 weekends. Excel is a skill where, if you learn it now, you'll use it the rest of your life, even if it's just for your own personal stuff. I was going to make a joke and say take a drink of my moonshine, but I actually used to know this teacher who would pour out half of their soda and then pour the rest in and get drunk in class and drive her kids home drunk and crash the car. And then my buddy divorced her, and it was just like, you got a problem. So maybe that's not such a good joke. So and then in my T-Lab, since we're through week 6, we're done with that. We're done with all of Word, and we're in our first week of Excel, which means down here you should do the Office lab test for Word, get that done, and you should be through Chapter 6 quiz this week, and that's it. And that's on track. And I know about 3/4 of you aren't anywhere near that, so get cracking. Otherwise, you're just going to keep falling further and further behind. You're going to be like one student who's taking my class again this semester because they procrastinated too much. And then they were like, I didn't get all my work done. I waited to the last minute and I ran out of minutes. So if that happens to you, I have no qualms failing you. And I'm sorry you didn't plan your time more effectively. So, you're in here. Realize your goal. Get through it. Do a little work each week. All right, so let's take a look at this stuff. I'm going to rename this week 04. See what's in here. And first we'll browse it. Secondary storage, magnetic. We know that stuff. Huh? I did.
Oh, okay.
Right? I don't know if we talked about this actually in here, so I figure I'll just go through it and see if it looks familiar. Does this diagram look familiar to you? No? Yeah, so let's look at that. Let's look at week 2. I'm pretty sure we did week 2. I'm not sad we're in week 6. I'm like, are we on week 2? That's a long time back. We did all that. Coding schemes, Gordon Moore, binary digits and bits, IPOS, RAM, BIOS. Yeah, we got all that. So this is what a hard drive looks like, magnetic hard drive. If you open it up, that's what it looks like. If you look at it more closely, that's what it looks like. Those are platters, and they're read-write heads. Those are those little arms. You can see how close they are. They're so close, in fact, they're closer than a smoke particle, closer than a dust particle, closer than a human hair. It's really close. And that's why it's a vulnerable place for computers that have hard disk drives, magnetic hard disk drives, as opposed to solid state hard disk drive. The magnetic read-write head can bounce against the disk surface and mess up the disk surface. It spins at like 7,200 RPM, revolutions per minute. So the way we store zeros and ones there, just with positive and negative charges. That's how magnetic storage works. One is, what's it say here? Yeah, so 1 is 0, 1 is 1, the other is 1, so positive, negative. And then optical media. I guess the other thing I'll say about hard disk drives is when you look for computers, let's make it practical. Laptops. Like the expensive laptops, well, that's on sale laptop. Let's do this one. Price, high to low. It says 512 gigabyte solid state drive. Okay, so you get less storage, but solid state drive. Versus down here for less money, you get a terabyte hard drive. Ooh, you get even more, but it's not solid state. That's a magnetic. So the magnetic is if you drop your computer or bang your computer, that read-write head could crash against the platter, so that's a vulnerable point. Solid state, you don't have that moving part. You can bang your laptop around a little bit more. It's more robust. Solid state's also quicker, faster access of the data. So that's why you pay more for less storage, but it's more robust and it's faster. So that's magnetic. Optical, CDs, DVDs, right? We store zeros and ones on a reflective surface. We make some of the surface reflective and some not reflective. And so when we shoot a laser at it, right, if the light bounces back, then that is, either a 1 or a 0, and then if it doesn't bounce back, that's the opposite, right? So that's how CDs work. And so you just are shooting a laser, and some of the parts of the CD are reflective, some aren't, and sometimes the laser bounces back, sometimes it doesn't. That's binary, 1 or the other, and we have 0 and 1. Fragmentation for hard disk drives. Sorry, I was just showing you magnetic. I got ahead of myself. I got to tell you one more thing here about magnetic. So there's optical. I thought I was looking at optical. So you can see the laser kind of being shot at it. And right there it's not bouncing back because it's hitting a little dark area, non-reflective area. One more thing I'll say about hard disk drives is the platter of the drive is organized into chunks, like those chunks. They're called clusters. The part of a track that crosses 2 or more adjacent sectors forms a cluster, the smallest addressable unit of disk storage, right? And so you have tracks which go around it, and you have sectors, which is different little pie slices of the track. And that's kind of how we divide it up, and then we store stuff there. And then we have a file allocation table of some sort. And so the file allocation table, if I store a file, let's say I save a Microsoft Word document, that file, it might be stored in a couple of different little clusters there, right? And so to store it, it might be like, part 1 of this file is stored in this cluster with this address. Part 2 is stored in this cluster with that address. Part 3 of the zeros and ones is stored in this cluster. And then to reassemble the file, it just goes and gets each of those pieces from the different clusters. That's called the file allocation table. And I don't have a pen to draw it. Let me see if there's a nice picture. Not nice pictures. That's all right. No, no pictures I like. So basically it's a table. We could do this. And so we have a file. And then a location where it's stored on the hard disk drive. And so the file might be Word, right? Letter.doc. And that might be stored in 12, 14, 17, and 19 in those different clusters. Okay? And hello, or me.jpg might be stored in 23, 87, 1009, 62. That might be where the zeros and ones for that file are stored. And when I delete a file, you guys done? When I delete a file, what gets deleted is this. All right? And that. But what those zeros and ones are still there. They're still in those cubby holes. All I deleted was this entry in the file allocation table. The zeros and ones are still there. So when you delete a file, that file's not gone. Those zeros and ones are still on your hard disk platter. There's no longer an association in the file allocation table or the NTFS or whatever systems used to track where the zeros and ones for this file on that hard drive. There's no longer an association, but those zeros and ones are still there. So the implication of that is if you just like sell a hard drive on eBay, I deleted all the files. Those zeros and ones are still there. So,
I have a question, but I thought a substitute of the location hard drive, like 12, 14, 17, 19, would be also deleted, yeah? So the memory is gone, no?
Okay. Just trying to think of an analogy. So on the hard drive, there are these zeros and ones, right? And let's say that these are locations 12, 14, 17, and 19 on the hard drive. And so here's the allocation table saying where those files are. Okay? And then this is the hard drive where they actually are, the zeros and ones are. And so when I'm like, oh, I need letter, okay, go to 12, 14, 17, 19, get the zeros and ones. Got them. I'm done with letter, let me delete it. So now my computer is free to use these spots because it knows, hey, I'm not storing anything in those spots. 12, 14, 17, 19 aren't being used. So my computer might come along and write some new zeros and ones there. But if it doesn't come along and do that, those zeros and ones are still there on the hard drive.
How can you delete it completely? Destroying them?
You're going to have a hard time getting data off of that. This is a good way. Take them to the shooting range, put a few bullets in them,
And that's how you get rid of them.
or just beat them with a pickaxe and throw them in the recycle them.
Did you use a magnet too? You would really help one.
Yeah, but that's not quite as reliable. And who has a strong magnet? You know, is it strong enough? You put a couple of bullets through a hard disk drive, and that data's going to be unreadable. So you could go onto eBay and you could buy hard disk drives. And then you could also go online and buy hard disk drive forensics tools. And you can plug the tool into the hard disk drive and you can read all the stuff that's there. People might think, hey, I've formatted my drive, all the data's gone. Microsoft said, warning, all data will be lost. Those zeros and ones are still there. Right? I deleted all the files. Cool. No, those zeros and ones are still there. And with forensics tools, you can pull them back out. That's kind of cool to know about. So the takeaway is when you're done with something, be done with it, get rid of it. And on the Mac, you even have File, Finder, Empty Trash, Secure Empty Trash. Empty Trash just deletes the entry in the registry. Okay, those spaces still have the zeros and ones, but they're open to be written over. Secure Empty Trash deletes the entry and writes jumbled zeros and ones over those slots. Just random zeros and ones. Okay. Of course, you know how to delete data on a CD or DVD. Just leave it in your car for a month. Get scratched up, you get Coke on it, Taco Bell burrito, no longer plays. Just kidding.
Not because of the heat in the car, not because of that.
Flash drives are a little bit nuts. Solid state versus hard disk drive. Input-output devices, we talked about that before I left. You know, there's some interesting stuff with scanners. There's like a flatbed scanner or Scantron, right? Or optical character recognition. That would be hard to recognize those characters. But you could, if you have a bunch of pages, just know that you could, like, and they're printed, typed, and you need a digital copy to edit them, you could take it to FedEx, Kinko's, no longer called FedEx, and just run it through their copiers, and they should have OCR, optical character recognition software, turn it all back into text, right? Those check numbers down there, old school magnetic ink character recognition for scanning. That's what those weird numbers are at the bottom, magnetic ink character recognition. You know, barcode scanners. RFID is pretty cool. So it's the size of an RFID chip. And when it gets near a scanner, it broadcasts a unique identification. So you could use RFIDs for, you know, I put a couple in my dogs. You can get RFIDs for pets, put them in your dogs. And if your dog is lost, the SPCA or the pound will scan your dog and be able to figure out who the dog belongs to. Livestock gets RFID'd. All right, someday maybe groceries will be RFID'd. There's a YouTube commercial that kind of shows this. You've seen it? Yeah, wow. Were you in my class before? Oh, cool. And then there's biometric scanners, biology, metric, measure, and retinal scans. That person's got pretty awesome eyes. I think that's been photoshopped. Retinal scans or fingerprint or whatever. How many people have got the iPhone that scans your fingerprint? Cool. I think that Apple probably has a larger fingerprint database now than the FBI, which is weird, you know? When we talk about monitors, we have a monitor, an image on a monitor is made up of a pixel, and a pixel stands for a picture element. Kind of cool. And so this image here is made of a bunch of dots. That's what a pixel is. It's a dot. And when I look at the resolution of my monitor, the resolution of my monitor tells me how many pixels I have on my screen, width by height. So if I was to look at the resolution of this monitor, whoa, best for creator. So here are different possible resolutions: 1920 by 1080, 1600 by 900, right? So that tells me 1920 by 1080, that's my resolution, number of pixels. So that's actually a lot of pixels. 1920 by 1080 means that there's 2,073,600 pixels to make up a screen size that was 1920 by 1080. Whoa, that's a lot of dots. So that's, resolution is the number of pixels. Resolution, width, height, number of pixels on your screen. And pixel is a picture element. There's some common resolutions. 1920 by 1080 is 16:9. So you can see here's the 16:9 line, and there's 1920 by 1080. That's a really common size. My Mac, for whatever reason, is more, I think, is 1610. Dang it. Kind of sucks. So for each pixel, we have to determine how many zeros and ones are we going to use to store color data. So if for each pixel we use 1 bit, 1 binary digit, we will have, what was it, 1920 by 1080, right? By 1 pixel, if the bit depth is 1 pixel, we'll have 2,073,600 binary digits if we had an image of that resolution that we need to store. That's the bit depth. If we add 16, well, let's just do 24. That's like true color. It's 49,766,400 binary digits, which are being stored for one image, or being used for one image. That's a lot. It's a lot of porch lights, right? You guys remember the porch lights deal? Right? Because each pixel has 24 zeros and ones. With 24 zeros and ones, we have 2 to the power of 24, 16,777,216 possible combinations. So that's 16 million, almost 17 million possible colors that could be represented. Spectrum, right? Shades of color. Now that's without any compression or algorithms to make things fancier or less data. Obviously, for this image, what's wrong, Google? Do you not like the German flag? Did I lose my internet? For this image here, right, we wanted to store that color information. It'd be stupid of us to store it raw, every single pixel. There's the data. Instead, we could use some sort of a compression, decompression algorithm. And that's like a JPEG or a PNG or a GIF. And that algorithm might have a mathematical formula that says, from this location to that location, it's all yellow. From this location to that location, this coordinate to that coordinate, it's all red. From this coordinate to that coordinate, it's all black. And then the algorithm just stores that information, which could be minuscule compared to 47 million zeros and ones. And then computers that know how to read that will then fill it in. Oh, from here to there, it's this color. Cool. Right? So you could do that with like German flag or French flag or any image, but those are easy to sort of visualize. Oh, that entire chunk's red, that entire chunk's yellow, that entire chunk's black. So that's a little bit about images too, not just monitors. Here's the color depth or bit depth. I forget which it's called, bit color depth. I think it's color depth. Color depth, also known as bit depth, number of bits used to indicate the color of a single pixel. So 24-bit is true color. And of course, you all should probably know, if you don't already, that you could set up your home computer to have multiple monitors. Right? Like right now, I have multiple monitors on this. I've got my desktop, and I have this overhead. And I could go into the settings, and right now my setting is display mirroring. But if I wanted to, I could have them just be two screens I'm working on. I could have crap on this screen, crap on that screen, and I could just be looking between one screen and the other screen. You know, and so I might have a setup like this at home with 3 screens or 2 screens. How many people have seen something like that before? Huh?
So then you can open a different program in each screen? How do you select
Different
the screen?
program in each screen. Surround yourself with blue light. For gaming, it looks pretty awesome. Whoa, look at that. That's crazy.
The black lines in between each one will bother me now.
Huh?
The black lines in between each one will bother me. The borders.
Yeah. That could be an issue. It's amazing how we could be persnickety about things. You know, it's like not just you, it's everybody, right? Like, why is my cell phone taking so long? It's going to space. It's communicating with a satellite. Give it a second. You're getting data from France, right? Like that used to take like my grandma 3 months to send a letter to France. She'd have to write it and put it on a ship. You know, like, why is it taking so long? It's 4 seconds. Yeah. I feel you.
First world problem.
First world problem. I like that saying. Then we have printers. So there's dot matrix printers, impact printers. They actually, like a typewriter, are pushing a pen against an ink ribbon, which is hitting the page. Or there are non-impact printers like inkjets or laser printers. So, you know, quality is pretty similar with inkjet versus laser. Sometimes they have laser ink, confusing names. Laser ink jet, ink printer, laser ink inkjet, laser inkjet. It's like, what? Shop for laser inkjet, laser jet, that's what's confusing. But it's laser or inkjet. So that's pretty much, you know, some of the stuff from week 3. Get rid of that spreadsheet. That's all right, actually. I'll just rename that. Maybe use that again. Week 3. How many people need a break? Raise your hand. Okay, let's take a break. One person half-heartedly raised their hand. So we just paused and watched YouTube. I closed it. Louis C.K. Generation. I'm not spelling it right. Louis C.K. Generation of Spoiled Idiots. We just watched that, 8:43. And then we also watched the IBM RFID commercial. This one. So you can go check those out. Take your own break. All right, but we're back. Now we're going to talk about week 4, even though we're in week 6. And here's a little diagram I want you guys to embed in your head. But basically, humans humans like to categorize stuff. So you might think about how we categorize cars, right? So, you know, one of the ways we categorize cars would be like cars or vehicles. And we might say cars, trucks, right? Whatever. You do that in your head. You've got categories. You got schemas like this, where you're just categorizing stuff. Academics like to take that and make it official. So when we talk about software, we divide it into system software and application software. System software can be broken up into operating systems, utilities, drivers, and translators. Okay, system software could be broken up into operating system, utilities, drivers, and translators. So system software is software that makes your system run. Application software are the applications you run on your system. The applications which you use your system for. So operating system, we all know what an operating system is. It's a piece of software which makes your system operate. An operating system makes your system operate. Name an operating system. What? Windows, I heard. Windows is an operating system. Microsoft Office is not an operating system. So Windows is an operating system. Name another operating system.
Mac have this OS 7 or OS.
Yeah, so Mac OS 10 has an operating system. iOS is an operating system for your iPhone. Android's got an operating system. I think it's called Android. I taught the class Android operating system. Android is a mobile operating system. That's the name of the operating system. iPhone has iOS. So with Android, we call it the Android phone, Android operating system. With iPhone, we call it iPhone, iOS operating system. Right? There's also Linux. Linux is a very popular operating system. It's based upon Unix. So Ubuntu is the most popular Linux operating system, probably for just replacing whatever you don't like on your current computer. So if you have an old computer, you can download Ubuntu and it'll run quicker than Windows and get rid of Windows. And then you'd have to Google, because you're going to download an ISO file, so you'll have to Google burn ISO to disk, right? Mac or Windows or whatever you're on. And you'll take that ISO file, you download, burn it to a disk, and they'll become a bootable disk. And then you can put it in your drive and just start your computer and see what happens. And most likely, you'll have to also then change boot order and put in whatever computer you have, Windows 10, Mac OS 10, and you change your boot order and say boot from the disk first, the CD, DVD, as opposed to the hard drive, and then it'll boot from that CD and it'll install Ubuntu, and you'll have a whole new operating system on your computer. Screw Windows. You got an old computer and it's running slow, get rid of it. And if Ubuntu runs too heavy, because it's like a 6-7-year-old computer, you could try light Linux distro. So you can see what are the best lightweight Linux distributions. And you can just read about that. And there's some really light ones. Require less processing. Because if processing power doubles every 18 months, so you buy a computer, it's got just processing power of 1. In 18 months, new computers are twice as powerful. In 36 months, new computers are 4 times as powerful, doubles again. In 54 months, they're 8 times. And in 72 months, they're 16 times. So in 6 years, the current computers are 16 times more powerful than your computer in just 6 years. And so the software is being written to take advantage of computers which are 16 times more powerful. And, your computer's sucking because it's built to lift 100 pounds and you're asking it to lift 1,600 pounds, so to speak, analogy. So you can put on an operating system which demands less resources. And then you can still use it for browsing the web and downloading your BitTorrent movies. Because if you get a virus, just wipe it out again. your legal BitTorrent movies. I was watching a video of a training a guy was doing. Occasionally he'd flash past his download folder and I'd see all these BitTorrent files. Who's downloaded television? So that's your operating system. Your utilities help your computer run well, just like utilities in your house help your house run well. Gas, plumbing, trash pickup. Those utilities help your house run well. Utilities in your computer help your computer run well. Antivirus software. I don't know, disk utilities, right? Like I could do this, and there's disk utility, and that's where I'd go to burn an ISO disk on a Mac, you know? So what if I just type in utility, disk utility, archive utility, voiceover utility. So those are utilities. Drivers tell your computer how to drive a piece of hardware. So if I bought a printer at a yard sale, HP LaserJet 1320 driver, I'd go to HP's website and I could find the driver for this. It's going to ask me what language, what's my operating system. So I'd say Mac OS 10. Confused. This is not 10.6. I guess I go with that one. And then it downloads it for me. Or I choose which ones I want. And then I install that, and then my computer knows how to make that printer work. So that's what a driver does. It allows your computer to drive certain hardware. Who cares about translators? So that software is broken up into system software, application software. System software is broken up into your operating system, your utilities, your drivers, and your translators. Translators translate from programming language to machine code. I should remove that. And then application software, you could categorize it all kinds of ways. Here it's categorized by license. Commercial, you pay for it. Shareware, freeware, open source, public domain. Public domain, if anybody uses it, you can do whatever you want with it. Intellectual property that's in the public domain is like, anybody remember that Nirvana song? Nirvana in the Pines. So that's a Nirvana song, but originally is an old Leadbelly song, a blues singer. But the song had slipped into the public domain because it gets so old and then it enters the public domain. And so, you know, anybody could record it and they don't have to pay royalties to anyone. So Nirvana made a recording of that song, and nice version, and they don't have to pay anybody. It's in the public domain. So some software could be in the public domain. Open source is like Linux or Go. Anybody could contribute to it. You could see the source code and look at how it was built. Freeware, shareware, nagware is like you could use it, but we might eventually charge you for it. Or we might nag you until you pay us. Or give you 30 days. But you don't own it. We own it. And commercial is just you pay for it. You never buy software. You buy a license to use the software. It's obvious when I say it. But if you bought the software, you could do whatever the heck you wanted with it. Go sell it at Blackstone and Shaw. Make a bunch of copies. See how long that lasts. Right? You don't own the software. You own a right to use it on your computer. So you bought a license. When we think about how software is laid out on top of our hardware, it's kind of that image. You got your hardware, and then you have your operating system, you have application software. And your operating system knows how to interface with your CPU and the hardware. And your application software knows how to interface with the operating system. So that's why you have to buy software for Mac or for Windows, because it's written to take advantage of those different operating systems. It also sort of delineates the responsibilities of the different pieces of software. So application software doesn't have to know how to make every printer in the world print. They just have to know how to take something that needs to be printed and give it to the operating system. The operating system knows how to work with the hardware, knows how to make it print, right? So that's what the operating system does. So obviously there's a whole bunch of different pieces of software that are out there. Mint.com is great for personal financial management. It's run by Intuit. And Intuit is a very reliable company. They make the Quicken and TurboTax. Pretty sure they make TurboTax. TurboTax, yeah. They also have Mint.com. You give them your passwords to all of your banks and credit cards, and then it's one location where you could see all of the transactions. And you could categorize all your transactions. This was for business. This was for pleasure. And then when it comes tax time, you could say, here's all the money I spent on my business. And you could write all that crap off. And that's how the rich people make money, right? Or keep their money. So there's word processing software like Microsoft Word or for writing documents. There's spreadsheet for working with numbers. There's databases for storing data. There's presentation software like the stuff I'm using right now. There are application suites, which is like a bundle of a whole bunch of different pieces of software, all for one low price. Browsers, we browse the web with them. Google Chrome is what you should be using. Graphics software like Photoshop allows us to manage images. Video editing software lets us edit movies, right? Web-based software like, I guess, Facebook. Or another classic web-based software would be Salesforce.com. Computer-based training, right? Minimum system requirements. Talks about what your system needs to be to run this piece of software. End-user license agreements, the ULA. So that's the thing you never read and you just accept. Piracy is stealing software or any intellectual property. Intellectual property is the counterpart to real property, like real estate. Real property is anything you could touch. Intellectual property is anything you can't touch, but which can still be owned. A song, right? A book, a screenplay, software. You know, you could print it out, you could touch it, but the real value isn't, you know, what you print and what you touch, and it's how those words are strung together to create, you know, For Whom the Bell Tolls, or to create this movie. I don't know, what's a movie that's out? Somebody tell me a movie that's out. Deadpool, to create Deadpool, right? The real value is the words, the dialogue, how the action's laid out. It's not the page that it's printed on. It's not the ink. It's the arrangement of those ideas. And that has value, and people can own that, right? Bruce Springsteen. I got the fortunes of heaven and diamonds and gold. I got all the riches, baby, that the bank can hold. I got houses across the country running end to end, and everybody buddy wants to be my friend, right? Bruce Springsteen, like the value is not the disc, it's the rhythm, it's the tempo, it's the cadence, it's the words, it's the guitar playing, right? So that's all intellectual property. You can't touch that. Touch guitar playing. You can play the guitar, but actually touch the music. Intellectual property. All right, so that's software. Week 4. See what week 05 has in store for us. More software and system software. You guys had enough? You want more? You want to do like 5 and 6 next? What's today? Wednesday? Want to do 5 and 6 next week? and then 7. Slowly get caught up instead of too much right now. And people want to do that. I'm kind of tuckered talking, so let's do that. Anybody got any questions? All right, do your work. Let me know if you get stuck.